Hi everyone! In this section we're going to look at an introduction to modeling using approximations. Now this could be done with a whole bunch of data points in a table, or you might even be given a scatter plot, in which case the scatter plots are what we are going to use today. Modeling is when data is reviewed and analyzed. By looking at the trends in the data, one can decide what function would be a good one to model the data with a process called regression. Now we'll talk about regression in the next section, but for now, to be able to identify the patterns in data will be particularly helpful to be able to name the basic function shapes. When analyzing the scatter plots, recognizing the shape of each function will become more and more beneficial as the section progresses. It will be particularly important to recognize the name for each function shape. For now, just focus on these particular function types. A linear function, that could be either a positive or a negative slope line, and the function for that would be f of x equals ax plus b. You might also recall that we used mx plus b in previous sections where we said y equals mx plus b. We're just using a instead of m because in your calculators, m has something to do with the dimensions of a matrix. Don't get too worried about that. Just suffice it to say a is replacing m for the slope. Now let's move on to the next one here, which is quadratic. You could have a parabola opening upwards or downwards, and whether it's a max or min, whether it's a happy face or sad face parabola, you will have a function f of x equals ax squared plus bx plus c. And if a is positive, it opens upward, and if a is negative, the function opens downward. All right, now let's look at logarithmic. Logarithmic functions might be something you haven't heard of in a while or ever. Logarithmic functions are something you will see a lot in how dense things get with respect to gravity. So like as you dig further down into dirt, you'll notice that the density becomes higher and higher. And so it has a logarithmic density. You could also talk about the shape of growth patterns. So when babies are born, they grow very fast until maybe their 12th month, and then they start slowing down growth-wise, and then they'll have another growth spurt, and in their, 2 to 6 years old, and then they'll slow down again, and that would be like their toddler years, and then again when they're teens. And so these logarithmic shapes are very common in real life applications. So a logarithm will always be to the right of the vertical axis unless there's been a transformation, but in general for us, logarithmic shapes look like this. And I'm going to go ahead and erase the vertical and horizontal axis. I want you to just focus on the fact that this logarithmic shape is very fast, increasing at first, and then it slows down over time. And that function would be written like this in regression. A plus b times ln, that represents a natural log. Don't worry too much about that right now. Just recognize the shape, that it is logarithmic, and this is the formula. And finally, exponential, which we've been looking at quite a bit recently. Exponential growth is very slow at first and then starts picking up speed very quickly. It increases very fast as numbers get larger, and also exponential decay, which is where it was very high at first and it slowly decreases to approach 0. This function has the form f of x equals ab raised to the x. This concludes our overview of the shapes of the functions we will be looking at when we are doing analysis on scatter plots.